Hi, welcome dear students to yet another video on data structures using C++. In this video, we are going to discuss how insertion sort works. So insertion sort is similar to the previous sorting algorithm which we have discussed, that is selection sort. In this algorithm, initially you will be given an array that is unsorted, and after that, two sub-arrays, sorted and unsorted parts, are created incrementally in each iteration. So before starting with the program, we will first discuss how the output is like so that we will get more understanding of how the program executes. So this is my sample output. So firstly, I have provided the size of the array, that is 6. After this, I am entering the elements in my unsorted array. Now, during the first iteration, the first element that is picked is 17. Alright, and after that, we will be taking next element 10 in our second iteration. So, what is the case in first iteration is that our first element is single, so it is already sorted. Now, when we take the second element that is 10, our next thing we have to do is we need to create a sorted array using these first two elements. Alright, so starting from 10, look back to the immediate previous element. So when 10 is taken, compare it with the immediate previous element. So 10 is compared with 17. 17 is greater, so we need to swap in between this. Okay, so since 17 is greater than 10, we need to swap. So what happens here is at the end of our second iteration, our two elements are in the sorted condition. So whatever to the left of an element will be in sorted condition. Towards the right will be the unsorted array. That is what we are having two subarrays. One is left side and another is right side. So ultimately after iteration 1, the elements to the left of index 1 element will be in sorted condition. So you can see here 17 left to it is sorted. After iteration 2, the elements to the left of element with index number 2 will be sorted while the right side will still be unsorted. So we can see here first 10 is compared with 17 and they are swapped because of the value. After that, in the second iteration, I am comparing 12. So initially I will compare 12 with 17. Alright, and after that we will be seeing that our value is greater. So this 12 is shifted to the left until we reach an element that is smaller than 12. Right, means if there was an element 15, then we had to shift one more time. All right, so since we have occurred an element that is smaller than 12, so we can stop it here. Okay, so our 17 will be shifted to the 12th place. Now in next iteration you can see here the element is 34. Now what is happening here is again 34 is compared with 17, and since the 17 is smaller than 34, we are not switching any places. Now our next element is 80. Again go back, compare the value, compare it with 34 first. Since it is fine, it is not greater than 80, so no need of swapping. Now ultimately we have reached the next iteration, which is value 33. Now what we have to do here is, here actually the procedure of insertion sort you can see in this step, that is 33 is firstly compared with 80. 80 is greater, so we need to move back. Now again 33 will be compared to previous element, that is 34. So we have seen 34 is again greater. Now we need to check with the value of 17. Now 17 is smaller than 33. So ultimately we understand that whatever to the left of 17 will also be smaller than 33. So ultimately we get the place for keeping 33, that is 33 is placed at, that is before 34, and all other elements will be shifted to the right. So what we are doing is, for every element we are identifying a position that is perfect for according to its value. Alright, so every element, after placing it at a particular position, every element to the left will be smaller, and in the right side it can be sorted or unsorted. Unsorted until you complete all the loop, and once you have completed your sorting, every element is in the sorted manner. Now finally moving to the program, I am using C++ to implement this particular sorting algorithm. So I have a class insertion sort. It has different methods: get data to receive my elements in the array. Firstly, I'm reading the size of the array, then I'm reading the elements of the array, and this method display is used for displaying the particular array. And after that, I have my ins sort method, which performs the actual implementation of the insertion sort. So we will go and see how it works. So my method ins sort, in this I am having a for loop to keep track of the elements in my sorted array. So I will be starting from I is equal to 1 because first element is already sorted. So what I can do is I will pick up the second element and compare it with the first element. So how this comparison occurs is, in my first iteration, I am keeping my first element in the temp variable. Now in this iteration, index 1 is compared with the element at index 0. Now check if the previous element is greater. Alright, if it is greater, shift the greater element to the right. Okay, so this step shows us the shifting. Now we will increment one more index and then see how it is happening. Now when you have index number 2, now in index number 2, we need to compare the indexes 1 and 0. So you can see here, this is an example that I have stated. So after first iteration, I will see that 6 and 12 will be swapped. Alright, 6 and 12 are swapped. Now, when my j value is 2, that is, I am here. I am at the value 18. So what 18 is doing is, it will be comparing the value with 12 and the value with 6. But the thing is, you can see the j value only decrements till 12 because this condition is getting unsatisfied. See, our array j minus 1 should be greater than temp value. When my temp value is 18, I can see that 12 is not greater than our current value. Alright, so my j value is at the correct location. That is, whatever to the left is smaller than 18 and rest part is, then again it is unsorted. Alright, so in case of index 2, actually we had to compare it with index 1 and index 0, but since our condition is already mismatched while comparison with 12, so we are exiting the loop and placing the temp at the j value itself. Here the j is not affected because it is already in the correct position. Same case will happen with 19. 19 will also give me the same thing. Going back, I will not see any element that is greater, so it is fine. But when the case comes for 11, what will happen here is, I will check the previous element. Previous element is greater, so I need to execute this step and I need to shift 19 to my previous next position, that is to the right. Now 11 will be compared to 18 again. Now 18 is also greater, so I have to shift 18 to the right. Again this step is executed, and after that I will compare 11 with 12. Again 12 is greater, so I need to shift 12 one more position, and finally when I compare 6 with 11, I will see that 6 is smaller than 12, so I don't have to decrement j value again and my condition is satisfied and I am exiting from the loop. And finally I have got my j value as index number 1, where this current 11 value will be placed. Alright, so you are just comparing immediate neighbors to going towards the back, and you are checking if the value is greater or not. Now finally exiting the loop, we will be getting the index position for the current value under consideration, and we have placed it to that particular index value that we received. So this is how an insertion sort algorithm works, and in our next video we will be discussing about quicksort. Thank you for watching this video. Thank you once again.